Hey everyone, very good afternoon. Welcome to the session on deep dive into Apex best practices for both apps and agents. My name is Mohit. I'm a principal developer advocate here at Salesforce, and I have the pleasure of having Daniel. Daniel?
Hello, I'm Daniel Bellinger, the product manager for Apex.
All right, so before we move, there's a forward-looking statement here. I mean, all the demos, everything is generally available. We are talking about generally available products, but because we have product management here, if we do make any forward-looking statement, please do not make your purchasing decisions based on them. With that, I want to take a moment and say thank you. Thank you for all the work that you do, and thank you for actually pushing us to innovate better. So with that, here we are with our agenda. So what are we going to talk about? So we're going to talk about really understanding, the system architecture here, like the constraints of the system, and really understanding like how to work with Salesforce platform for Apex developers here. So we'll be talking about a lot of things that we see on the field here that developers often struggle with. So we'll be talking about how to design your asynchronous Apex. Trigger recursions are another common problem that we have seen. So we'll discuss that. We'll talk about how to manage concurrency and record locking. We'll give you some performance best practices tips. And a lot of you have large data volumes, so we'll definitely touch base on that, like how to work with Apex for large data volume. And then finally, we'll share some system monitoring tools and best practices. So with that, let's get started. Daniel,
right, yeah, maybe we'll run through designing async processes. It's quite a common scenario for Apex. Oops, that's the wrong button. I'll go forward. OK, so most people, when they think of asynchronous processing in Apex, they will start with batch. Batch is great, but there's a number of things you need to consider when you're processing records through that. First and foremost is batch technically has no SLA, which means as a multi-tenant environment, we'll run the jobs up and down, and we'll run them as soon as we can, but there could be some delay before those jobs start running. So you need to consider that in your processes and in the timing that they're going to have when they start running. So for example, if there are delays, you need to be prepared that your batch job might not run immediately when it should. And that could cause secondary flow-on effects. So you might have two batch jobs. You might end up with two of the same batch job trying to run over the same set of data. You might also have to consider what your users will experience. You don't typically want to use batch jobs when a user is expecting to wait on the output. Batch is for working over large volumes of records asynchronously in the background when nobody is waiting. And then, of course, if you do end up with two jobs trying to run over the same set of data, you need to make considerations in your jobs like, can I actually handle that? Am I going to run into locking issues? How is that going to scale? I think we have a demo of that, don't we, Mo?
Yeah, absolutely. Let's look at the code behind one of the batch classes we have. So this is a simple batch class again, nothing complex. So we call this class as data processing batch, as you can see. And one of the things that you will see here that I'm doing is I'm able to get the batch class job ID from the class name. And then what I'm doing here is trying to query this object called async apex job, because this has everything that is there in the processing and the queued state. So I look at, if there is a job already existing. If there is one, then I simply decide to throw an exception. And this is where you could also reschedule the job to a later time. But really the key is, I'm making sure that there is nothing already in the processing or queue state for the same job, so that I have a clean processing here. So this is one of the tips and best practices, again, as Dan said, because there's no like SLAs, right? You might think that you might design your system assuming that, let's execute this job at 7 a.m. itself. But in reality, that's not how it works. We'll try to make every effort to run at, say 7 a.m. in the morning, but that job might just get delayed because of multi-tenant architecture, and it might run at 8 a.m. So you shouldn't depend on this because there's no SLA for us.
Correct, yeah. Right, so with that, let's go on to the next asynchronous feature that a lot of people consider, which is queuable jobs. Queuable jobs are much better suited for if you're doing processing for smaller batches of records for individual users, but there's still considerations. There's still technically no SLA on how fast they'll run. So when you're implementing them, you need to bring that into consideration of how fast are my jobs going to run? How fast is the user expecting a response back? Now, there's a balancing act to be made here. Obviously, you've gone to asynchronous processing because you wanted to use higher CPU limits, higher heap limits. you want to do more processing than a synchronous transaction would allow you to do. But obviously, the balancing part is the faster you can turn these jobs over, the more we can run for you, the more you'll be able to throughput. So always a bit of a consideration there, like does this need to be done now? Does it need to be done fast? Who's waiting for the response? Now, the other part is, obviously we've tried to give you some tools. We've given you some tools that will help you execute your jobs more efficiently and faster. The first and foremost thing is to protect yourself from like a runaway recursive job. That can be quite catastrophic for your processing throughput. So we've given you a depth control. When you enqueue your job, you can say, this should never run to say more than a depth of 100, and if it does, just terminate it. That's an excellent mechanism as a safety procedure to stop you burning through your limit for the day. A couple of other features we've given you there is the ability to give an explicit delay before the job should run in minutes. So you can say up to 10 minutes, wait before even trying to start running this job. This is great in scenarios where you might be waiting to do like synchronization with an external system, where you know it's not going to have a response within 30 seconds. There's no point in trying it immediately. Might as well wait a few minutes and be more efficient when I do actually run. And then the third part there is a deduplication key. So if you have multiple things that could be enqueuing that job, but you know they're all going to try and process the same record, or maybe it's even as simple as something as you've got a user who likes to mash the same button on the user interface again and again and again and again, you can put the deduplication key in there and only one of those jobs will actually run and the rest will get rejected. Saves you a lot on your limit usage. I think, do we have an example there as well, Mo?
Yeah, but how about do we talk about transaction finalizer?
Oh yes, yeah, I always forget, and then it's the last thing. Okay, so at the end of your transaction, it's quite often necessary to say like, do I need to write out some data based on that transaction completing, or maybe my transaction didn't actually complete. Maybe there was an exception somewhere in my process. And in that case, we can use transaction finalizers attached to that queuable job and actually use that transaction finalizer to handle the exception. Like you can't catch and handle a heap or a CPU exception in any other mechanism. And you can also do finalizing DML and other operations in that. So it's a great mechanism to use with your queuables. And now we have a demo with both of those things.
Yeah, let's actually take a simple example called robust queuable class. So if you take a look at this class, right, this is a queuable class, but one thing I've done here is make sure to attach a transaction finalizer. And that is what my request, look at all your queuable jobs that you have in the org, make sure that there is a finalizer class for that. And why we need that retry finalizer class, it's pretty simple. It's because, there are exceptions, as Daniel said, there could be exceptions in, like CPU timeout or governor limit or maybe unhandled exception, and you would want to retry after some time. So you could get all that information if you attach a finalizer. So a finalizer class implements a finalizer, and here you can get the context and you can see that, you can look at the parent job result and find the exception and retry based on the exception type. There are different exception types here in this job result. And the other thing that we talked about is the depth control, right? You can always get the current stack depth, right? If you have if you're retrying for multiple times, there is often a time where you want to say, okay, this is the maximum depth I want you to try, and after that maybe just log that as a in the maybe a custom object log or maybe a platform event, or maybe if you're using an open source logger or something like that, you want to inform there. And the last thing we want to say is deduplication. And we talked about this, right? A lot of times, right, you might have a button, and the user might just click double time. So there are double jobs that are queued now, right? And you want to avoid that side effect. And that's why we cannot give you, because that can run two jobs working on the same set of records. They can just lock themselves up, and the system won't behave as you want. So in that case, you need a duplicate signature. So we've given this async options like this. So when you are invoking your job, right, you could just pass in that async options like this, and it will have the duplicate signature for you too. Make sure that if there is a duplicate job, the system takes care of itself. All right, with that, let's talk about another asynchronous mechanisms that we give to the developers, platform events, right? How many of you use platform events? Okay, many of you have used platform events, okay. So how does these platform events work, right? So they are processed synchronously on platform despite they are invoked asynchronously. They will be invoked asynchronously, but they are processed synchronously. That means the synchronous governor limits apply to them, not the async limits. And one of the advantages though, even though they process synchronously like other mechanisms that we have, you can really better manage the governor limits because it's not fixed size. If you look at triggers, let's say you have thousands records, right, coming into the system. We batch by 200. We batch them by 200, and that's a fixed number, right? There's no flexibility there. That's not true with platform events. You have a choice as a developer. So based on how much capacity a process takes, you could adjust that number. You could go from, I think, 200 to 2,000 max.
Yeah, 2,000 is the max.
So if you can process more, we'll choose a higher batch size. Mm-hmm. And then finally, one of the key differences or key mechanisms that platform events provide is built-in retry mechanism. This is awesome because if there are errors, the platform events can retry itself to fix it. And we're going to take an example. But before I begin, there's another point to consider, which is event delivery of these platform events cannot be guaranteed because they are distributed. But we provide a callback handler that you as a developer can implement to identify and republish those failed events. So how about we take an example to look at it, right? So demo example. So the example that I have is pretty simple, actually. Let's close other tabs so it's easier to view. So the example that I have is a simple low ink trigger. It's basically a platform event trigger. You can see there is this low ink. So imagine there are platform events coming from printers, and these printers are running out of inks. And this little bit of code you can ignore because this is for telemetry purposes. It's another platform event that I'm launching, and basically I built a UI where you can see some of these. And I'll share the code where you can deploy and see them. But the crucial thing to understand here is if you look at the trigger context here, right, there is this thing called event bus.retriable exception. So when you use this, what happens is the system takes the whole batch and retries it. This is very good if you're running into row lock issues because system might be busy at that time, so you just want to retry. So this retriable exception is really good if your system errors are transient and they can fix themselves. Like for example, in this case, right, it might be a resource issue. So maybe retrying fixes that resource issue, like row lock issues, right? So you just throw a retriable exception. Of course, you can also depth control them. And same thing for external service. Let's say you have an external service which is really busy when you're calling through the platform event, right? When you're calling this, when you have an Apex, which gets invoked through platform event, and when you're calling this service, but let's say the service can fix it, it can fix itself. So you might want to just have your platform event retry again by using that, by throwing this retriable exception. Now here's an interesting thing. Sometimes, so the previous mechanism, right, it is for the exceptions that can fix, like transient errors. But sometimes, like for example, governor limits, right, where what happens is you don't want your whole batch to again retry. Maybe you had 100 records in which 50 of them just passed. Maybe you have 50 of them that just got failed, and you just want these 50 records to retry. In that case, we have this, on the event bus, we have this trigger context.current context, so where you can set a resume checkpoint. And the idea again here is if you're running into governor limits, it will just take the things that are not processed. It will just take those records and will try to reprocess only those records, fixing the batch size itself to retry and fix itself. So if you're running into governor limits with that, this is the mechanism to try. Okay. Here in this case, I'm also catching the exceptions in case I also want to try using retriable. So you could have both as well. You can design in a really fail-safe way by having both. How about, Daniel, we just, other thing I missed, they can also parallel process, like platform events.
Yes, so maybe we can go into that.
Yeah.
And then what considerations do you need to make if you're actually going to parallel process your events that are coming out via platform events? This is a relatively new feature, and it's probably easiest to look at an example. So traditionally, when you fire your platform events, obviously they run asynchronously, they're platform events, but they would run sequentially through the order in which the events came in. Well, as a new feature, you can now actually petition and run multiple subscriptions to the same event. And so what that does is obviously increases your throughput. But the key feature to consider here is how are you going to divide those jobs into those petitions? Now, if ordering is important, so if you just chose a random thing to petition on, the events are going to spread out randomly. And you might see in like a scenario like this, event 2 could actually be processed before event 1 is, because they're running in different parallel subscriptions. So if the ordering of your events is important within a particular petition, you need to choose a petition key that will put all the events into the same subscriber. Now, converse to that, if you want like a distributed, evenly balanced load for all your events, you want them to go through with maximum throughput, you want to choose a petition key that will be like evenly distributed. So something like a sequential key that's getting assigned will distribute them evenly between all the subscribers. So there's a balancing act there between like, do I need them to run in a particular sequence, or do I want to like maximize throughput? And I think we can have up to 10 subscribers.
That's correct, yes.
Yeah, great. So yeah, an overview. We try and actually, the names here for the various asynchronous processing things are actually reasonable. Batch jobs are for when you want to run large batches over large volumes of records. Not necessarily fast, but you're going to process them over a period of time. You can scale up quite significantly, but don't expect immediate responses. If you want something more with a faster turnaround time, queuables are ideal for that. They have lots of flexible mechanisms. You can actually split out to running 50 parallel jobs and 50 queuable jobs in parallel if required. And there's various mechanisms there for chaining them, running transaction finalizers, etc. And then if you're more event-based, you want to reach out to external systems or do other different alternative to running parallel jobs, you can use platform events there.
Awesome. Now let's talk about something different, which is asynchronous actions in agents. How many of you are using or seen agents and building with agents? Oh, not a lot of you, but some of you have got started. So I thought we'll keep this option. Sometimes, right, when you are building these agents, some of the actions that you design might be asynchronous in nature, right? For example, let's imagine you're booking a cinema ticket. That process might take a lot of time because there is a call out to an external system. Maybe there are a bunch of things that needs to happen in Salesforce, etc. So it might take time. But you cannot have your user sit on the user interface and wait for it. That's not a good experience, because when you think about conversational experience, everything has to be faster, and that's the power of the experience that you get with agents. It's like it's conversational, it's faster, where the users can just conversationally ask what the system needs to accomplish. Now, in this scenario, right, I would recommend that the best practice is respond immediately, do all the things you can do immediately, and just respond with an ID saying, hey, this is your ID. You can really use this ID to ask for the status later. Or the other alternative is obviously when the processing gets complete, you send them a final result via an email or a text message that this request has been accomplished. So how about we actually take an example and show them through a demo?
Yeah, make it more concrete.
Yeah, let's take a look at a demo. So this is Agent Builder. This is where you test and build these agents. And I have a simple topic to show you, reservation management, which is meant for handling reservations. So it's agent that's going to help with creating bookings, managing reservations. And if you look at the actions, there's a bunch of actions, and one of the core actions is creating bookings actually. So, but creation of booking is an async action here, okay? So what I want to do is a little bit run this action and kind of show you how I kind of build this action, right? So now I lost my prompt. Let's just retry the prompt in a real time. So I'm going to say, hey, I want to reserve a slot. For, let's pick a contact. I think I know the contact. It's called Sam Edwards. Sam Edwards. It's a contact that exists in my system. For the session,
Pretty sure he wants to come and see this session.
Yeah.
You have the name of the session?
Yeah, the session is called Apex Best Practices for Agentforce, right? Agent Best Practices for Agentforce, and you can see there's no bookings here. Wait, let's refresh. It's been sitting there for some time here. Okay, so this is the session, and again, it has no bookings, as you can see. We want to book Sam Edwards for this session, basically, and there is an action that I've built. So I'm gonna start asking the agent to help me with reserving a slot for Sam Edwards. Now this is an asynchronous process, and I can show you. As this thing gets completed, now the agent is again reasoning, it's going to finally execute that Apex action. So as you can see, it just came back and it said, yeah, it created that reservation record, and the booking got created, but you see the status as pending, right? So if you look at this related list record, I have to refresh it to show you. So there's the record that it created, and the queuable job ran, and it got completed. But then the idea is for the user, right, for the better experience, they can just ask now. Like I can say, what's the status of, what's the status of the booking, and just put the booking
you lost
number.
your B.
Yeah, it has to be correct, So what's the status? Now, it's going to use the query action, basically look at that record and say, okay, it's in the completed status. So you see, your jobs can be a long-running async process, but you still can manage, So you see, it says it's completed. How else can I assist you? So how is this thing built? Let's actually look at the Apex code that is doing the magic for this. So this is an example again, create asynchronous. Let's expand. So really, I want to show you things here. So first of all, if you're building agent force actions, they need to be invocable. So now it takes both session ID and the contact ID as the request. And then these are the response variables. But key thing is make sure that you provide description, because that is how these agents learn what these variables are for. And then if you look at the booking, again, you want to make sure that you provide a clear description for your action. And really what I'm doing here is looking if there are any existing bookings. So I have all my business logic here, whether I want to avoid double booking. I also want to check the session capacity here, but then really create that booking record in the pending state, but then kick off an enqueuable job here and make sure that that job gets executed in a queuable class. But key thing, Daniel, to understand here is there are a couple of things to understand. First, remember that I have all my business logic in this action. We'll talk about the implications of this. But really very interesting thing to note here is I was able to push this job asynchronously, right? And still synchronously show to the user interface the status, the current status. So that's really an important thing to understand. And now we want to move on to a different topic here, like trigger recursions.
Yeah, so any Apex process, including those that are firing from Apex actions, need to consider what happens when your triggers start firing. And trigger recursion is usually the largest thing that's going to catch people out. Now, there's various mechanisms for handling trigger recursion, but there's two that are pretty well understood and quite robust. So if you've got something like an update trigger, you want to decide, should my trigger body fire? Usually it's best to make the decision based on the differences between the old record and the new record, like compare the value of two fields. Now I know this says trigger old, and in reality you'll probably loop through the trigger new map and then find the corresponding old value of that S object via the trigger old map based on the ID of the record you're looking at. So you'll compare the two values and say, yes, my trigger should fire, or no, it shouldn't. And that's quite a robust trigger mechanism for update triggers. But another scenario is like a before trigger or an insert trigger. What are you going to do in those scenarios? Now, if you do an internet search, you'll probably see something that says use static booleans. That's true, but you also have to be careful in how you do that, and there's special considerations you need to make. So at the start of your trigger, you'll set your trigger boolean to say, yes, true, I'm running my trigger. You'll do some internal DML operations, which will do recursive operations, and you'll be able to put a guard there to say, no, don't fire my trigger again. But then when you get to the end of the trigger, and this is the most important part, you need to reset that boolean back to false so that any re-entry into that trigger through other mechanisms comes into account. And I think, do we talk about the next slide? I think we do.
Yeah, let's talk about it and then we can show some demo.
So those edge cases are actually where that pattern is really important. So the biggest edge case that catches a lot of people out is partial save behavior. So you go to insert, say, 200 contact records. If that's coming from like a all or none equals false scenario, you will go to put 200 records in, 50 of them might fail. The trigger will actually fire again for those previous 150 records. So you'll see them again. So if you've done something like used a map to say, I've seen these IDs, I've seen these records, or a set, that's not going to work because those are already going to be in that collection. So you need to make sure you reset that static and not use that type of mechanism. I think, that talks about it more. So database insert, database update. By default, they'll be all or none equals true, so it's not necessarily an issue there. but it's especially an issue when you're dealing with all or none equals false. And the other major scenario that will trigger that off is obviously bulkification. If you're putting more than 200 records, if you've got 400, your trigger is going to fire at least twice. So those are important considerations to make. The other part of that is an inbound API request that might be doing DML on those operations or those records that's going to fire your triggers. Those default to all or none, the equivalent of all or none equals false anyway. You are going to see retries in your triggers for the same records multiple times. So you need to be able to have a mechanism that can, in your trigger recursion protection, that makes allowances for that. Do we have an example for that, Mike?
Yes, definitely. I have some examples here that we could show just to make these concepts really clear. So let's look at some of the trigger recursion examples. So first example that I want to show you is definitely the update scenario, right? It's very simple. All you do is look at the old map, like you pass in your trigger.old map and new map, sorry, not new map. You can pass new map too, but trigger.new, and you look at the differences, and that's it. You know, it's intelligent enough to handle trigger recursions. But the scenario that we were talking about just now is a little different. For example, this scenario where I have a trigger basically on an account that creates a task, and then there's a trigger on a task which looks at the task description and says if the description has something regarding some competitor's account, create an account. Now it will create an account because we have recursion, it will create a task, it will create an account. So you see that it gets into the loop. So it's an insert scenario, so there's no trigger.old map here for us to help, right? So as I said, only way to solve this is have a Boolean. But then very important thing to remember is you initially set the Boolean to true, and then you accomplish what you want to do, but you have to unset it back to false. And that is very important. A lot of times we have seen that they use these static Booleans and maps or whatnot, but they forget to reset it. If you don't reset it like this, what happens is if you have more than let's say partial behaviors. I think the sets can handle that the batching behavior, but they will not be able to, sets or a map or even the Boolean, right? It will not be able to handle the partial safe behavior when the system tries to retry itself. You're stopping that system behavior basically. So that's why it's very important to reset it. Okay, so hopefully this tip kind of helps you. And then the last thing, again, avoid using static Boolean, static maps if possible. Definitely not in update scenarios, you should avoid it. But for insert scenarios, if you do use Booleans, just make sure they are reset. Other thing I want to talk about are triggers in agentic world. Like what happens to these triggers when you have agents? How should you think about them? This is something that we really want to discuss here. So remember that the whole idea behind these agents, as per me, is it really provides an enhanced user experience. Like they can be on agents, they can ask agents to deliver tasks, and the agents could be doing this task. So agents definitely offer a new and improved way to build user experiences. There's no question on that, right? But if your users are always be on this agent, I think it's a best practice to have your business logic in the agent action. Okay, in the action, you saw the action that I built. That definitely had all the business logic there. So then there is no point in having triggers. Okay, if your users are strictly going to be using agents, I think trigger is an overkill. Because what happens is if you have logic in two different places, you'll have to debug at two different places. Why not just have it in the action itself? It's pretty cleaner architecture, easier to debug. But other thing is these agents can now be called through flows, record triggered automation. But I want to make sure that if you're doing that, always for bulk processing, make sure that your actions can take care of this and you have switches implemented. Now remember, that's not the case, right? When you are in this world where you're still moving into agents and debating about whether to use agents or not, you are still in this world, right? Real world, real actual world, where both agents and app exist. That means your users are going to be creating data to the app, also to the agents, maybe through APIs, etc. There are multiple places. In that case, it is very important to keep all your validations and system logic in Apex triggers. Okay? And then managing the trigger behavior, again, you should definitely have a way to manage your trigger behaviors.
I mean, as you say, like the scenarios like bulk loading records.
Yes.
People already have trigger handler frameworks for that.
Yes.
To disable them in that case, you'll probably need some sort of similar mechanism.
Yes, sometimes, sometimes you might want certain actions to, really stop for a particular use case. Like you don't want that system action to happen from agent. In that case, we already talked about that static booleans are the way to go about it. But make sure you reset them again. And then, other thing to understand is when you're working with Apex and agents, remember that, when you are building a record-triggered automation workflows, using Apex, you yourself are orchestrating these actions. You are creating these complex nodes. And really, you're adding, once you add a lot of requirements, they become huge. Remember the flows, they can be large. Same thing with Apex, they can be hard, right? And agentic experience really simplifies this because agents are gonna orchestrate the thing for you. But again, remember the bulk upload caution, always make sure that you understand that when agents are operating, they're also making callouts. So that's why you need to definitely have that switch in place to turn them off during bulk uploads and things like that. All right, let's move on to managing concurrency and record locking. How about Dan, you take us through this?
So the first thing you need to usually consider when you're working with large volumes of records is what does the ownership or SKU of those records look like? So you can imagine if you had say one account and you tried to put 5,000 contacts on that, whenever you try and update that particular account, those particular contacts, all of them are going to need to potentially do locking-based operations back to the parent account. So you really need to consider how balanced the data structure is, how distributed it is between various records to avoid that sort of skew issue. And there's also other related things there. So if you have one individual user, you probably don't want to assign every possible case that gets created to that one user. You're going to have the same sort of locking and related issues there. Generally, Salesforce is actually pretty good at handling locking issues that might occur. You'll typically retry operations, you'll get a message, you can resume from that, or it will wait long enough that it can resolve that itself for you. Now in Apex, you actually have specific controls. You can use forUpdate to lock individual records while you're processing them. That means nothing else can come along in the system while you hold that individual lock for that record. That's quite an important mechanism to use when necessary. Okay, so something we've recently launched, you'll see it in the current release notes, is the concurrent long-running request limit in Apex. This now scales based on the volume of licenses in the org. So naturally larger companies will have a naturally larger concurrent long-running request limit up to 50. So that basically keeps things in scale with the size of the organization that you're working with. And then if you do run into concurrent issues, like say this record is locked, usually a retry will resolve that, get past that contention. Although as we mentioned earlier, batch jobs or anything trying to process over those same records, you might need to make special considerations to avoid that.
Awesome, and Scale Center is your best friend when it comes to diagnosing it. It can spot and tell which records went into the record locking state, which user caused it, which process caused it. So it really gives a really nice monitoring tool. And then there is an edge case scenario that we want to talk about, right?
Yes, so if you are in your Apex code, you've taken a forUpdate lock, you think I have exclusive access to this record, and then you make a call out to express something about that record to an external system, we actually drop that lock. We can't hold it. We can't hold the database lock for 2 minutes while your call out completes, so it gets dropped. It's reasonably silent in its dropping of that. It is documented. If you have the debug logs, you will see an entry in there that tells you it's dropped the lock, but it's definitely something to be aware of. You might be surprised that your lock isn't actually there anymore.
Yeah.
And the other thing is in Apex, you can establish a save point around a DML operation to do rollbacks for you, but save points will block callouts, and if you want to make a callout, you have to explicitly roll back that save point and then release it, and that will. But any forUpdate locks that were established within that save point will be dropped.
Yeah, and we do have an example here in the sample code, and we'll share all the sample code with you. But if you look at an example that I have, I definitely show you that behavior. So really, what Daniel is saying is, even if you put forUpdate here and if you make call out, this forUpdate doesn't stop from locking this record. This is unlocked. And if any process comes and modifies this, let's say you have a Kubel process that is running, it will go modify the data automatically. Even though you have put a forUpdate, we are not locking it because the call out happens. And by the time this call out comes back, maybe this record data is changed. So there is data inconsistency that happens. Now what you could do though is you could do this prevention by using a save point. So you put a save point here, And then, if you want to make a call out, you can be explicitly releasing that save point.
Yeah, so they're releasing that save point will drop the lock. Yeah.
Yeah, drop that lock. But again, as a best practice though, Danielle, we always recommend that, perform Apex callouts, before, kind of do your
and then you can take the locks just for the shortest period of time, get your updates done, and keep the database consistent.
Awesome, awesome. All right, let's move on to the performance best practices here. Again, you have to think about your processes, what you're trying to solve, balance between synchronous and asynchronous. Sometimes asynchronous makes sense because those things can happen asynchronously. So you kick off in asynchronous. Sometimes you want them to be synchronous. So balance, think about, don't put everything in synchronous process because there's only 10 seconds of CPU that you have. You might run out of CPU, And again, if you put too much asynchronous process, there's limits on number of asynchronous process. So again, you have to balance. Another thing is platform cache. So that is another thing. If you can, if your data is like static over your session, you can use platform cache to hold it. And avoid global describes. You really don't need them.
That's a particularly expensive one. You don't really want to be describing the entire state of the universe and then throwing 99% of it away for the one object you were interested in. Use the much more specific calls to just describe the metadata on the objects you're interested in.
Perfect. And then let's talk about the CPU efficiency. Again, there are a lot of monitoring tools here like Apex Guru that can really spot CPU inefficiencies. So please take a look at those tools. And then, sometimes the computation can be so heavy that Apex is not meant for. I've seen developers like trying to use Apex for, these computation heavy tasks. Like sometimes I've seen developers using Apex for image processing, zip, although now that we have zip capability natively built. But some of these processes can process using other tools that we have like Heroku. Sometimes you have resource intensive tasks that Apex cannot do. It's too resource intensive. You can create a service on Heroku. You can provide the necessary scaling in terms of adding more horizontal and vertical scaling. And then expose that service as external actions within Apex. And then it becomes very simple architecture because now, you can just call that Apex service. Heroku runs that service for you. It's because it's very computational heavy, it will run the process for you and then come back and store the output of the process back into your records. So this is how you scale. And then let's talk about working with large data volumes. We've seen, developers sort of struggling with these large data volumes. That's because, again, Salesforce is meant for transactional volumes, okay? If you have a big volume of data, use Data Cloud. Data Cloud can scale up to billions of records. We have built-in connectors to Salesforce. We are investing in features like calculated insights, enrichments, and data actions that are very similar to what the capabilities we give in the Salesforce core platform. And Apex, thanks to Apex team, because now they have ways to query that data from Apex. Like you can query that same data in Data Cloud through Apex. And there is a connect API now to allow you to query that data in Data Cloud using SQL. So you can have an Apex service where you can write SQL, and that will query the Data Cloud. So you see how you can use the powerful LDV capabilities of Data Cloud to power your applications, right? So you can think of IoT data or any large volume data. They can be sitting in Data Cloud, and you can relate it with Salesforce objects. Like you can have a parent object in Salesforce, all these large volume objects in Data Cloud, you can relate them through features like enrichments, and that's going to allow you to scale better. Now let's talk about tools that we give you for monitoring some of these. So one of the tools that I want to talk about is event monitoring.
Yes, so that's a recent feature we launched. You now have a free tier of event monitoring for the unhandled Apex exceptions. That's a great way to pull that CSV down. It'll give you the last 24 hours of exceptions. And rather than using the emails, you'll be able to capture each and every message in a format that's then easy to process at volume. So it's really important to be aware of what volume of exceptions you're throwing out of your org that you might not have seen otherwise.
And it's free. Like the event monitoring does cost, but for Apex developers, all the Apex exceptions, it's freely available.
Yeah, free for the last 24 hours.
Yeah, free for the last 24 hours. And again, Scale Center, Scale Test, agent monitoring tools. Please make use of these tools because they can really help with monitoring, And lastly, all the code that we just shared, there is this URL. Please go through this URL. We have all the sample code that we just showed you. And finally, I want to take a moment and say thank you.
You go back a slide. People want to get a photo.
Oh, yes, sorry, yeah. Let's go back here and please take a screenshot of this or bookmark this URL. And again, thank you for joining our session. We'll be downstairs here, so we can take your questions.
Cool.
Thank you again.
Thank you, everyone.